Now we're going to look at problem solving with inequalities, and a lot of times these are difficult to interpret. So I try to think of a real world example where we have like less than and greater than, and probably the thing that comes to mind first is like an amusement park and rides. There's usually a sign in front of a roller coaster that says you have to be at least this tall. Or on the little kiddie rides, there's usually a sign that says at the most you can be this tall. So I try to think of it in those terms, and then it makes more sense to me. So like on number 1, x is at least 5. Well, at least 5 implies that it can be greater than 5 or equal to 5. But 5 is the minimum. It can be anything above that. A lot of times we see the word least and we assume less than. But at least means 5 is the smallest, and it can be anything more than that. X is at most 5. Well, that's going to be B. X is less than or equal to 5, meaning it can still be 5, but that's the highest it can be. Number 3, X cannot exceed 5. That is also B. It can be 5, and it can be anything less than 5, but it can't be more than that. 4, must exceed 5. So it cannot be 5 at all. It has to be greater than 5. So that is option C. X is no more than 5. Well, that's B. No more than 5 means it can be 5, and it can be less than 5, but it can't be more than 5. And 6, D, is X is no less than 5. So no less than 5 means it can be 5, and it can be higher than 5, but not less than 5. So again, these can be confusing, but think of it in terms of something that's familiar to you. And like for me, it's roller coaster signs. So now let's translate these. So no solving involved, we're just translating. So a number is at most 13. So a number is at most 13, so it can be 13, so it's going to have the equal to. The question is it less than or greater than? Well, it's going to be less than, because 13 is the most it can be, but it can be less than that. The coffee weighs more than 2 pounds. So more than 2 would imply greater than 2. It's not going to equal 2, it weighs more than that. Number 9. The speed of the car was between 45 and 65. So I'll use C for car, and it's literally between 45 and 65. So that means it has to be less than 65, but greater than 45. And it looks like I have the same symbol there because they're both facing the same direction. But when you're reading inequalities, you read from the variable first. So if I read from the C first, I can say C is less than 5, or I can say C is greater than 45. And the way I remember that is if the gap comes first, that's greater than. G gap, greater, G less than, it looks like a slanted L. So that's kind of how I remember that. But if you read it from the variable first and the point comes first, that's less than. If you read it and the gap comes first, that's greater than. And finally, number 10, a number is greater than 10. Well, that one's pretty straightforward. So a number is greater than 10. Okay, here's a few more. A number is less than or equal to 50. Again, that one's pretty straightforward. A number is less than or equal to 50. Those are the easy ones. The cost is at least $45.60. So the cost, it can equal $45.60. Again, the question is it greater than or less than? Well, it's at least, so it's going to be greater than or equal to $45.60. $45.60 is the least amount or the smallest amount. 13, we have the amount spent on advertising is not to exceed $1,500. So not to exceed. So it can equal $1,500, but it must be less than or equal to that number because it cannot exceed it. And 14. 5 more than 1/2 of a number. So 5 more than implies that we're adding 5 to something. We're adding it to 1/2 of a number. So 1/2 of a number plus 5 is no less than 16, or negative 16. So negative 16 is going to be over here. No less than means it has to be greater than or equal. It can equal the negative 16, but it can't be less than that. So that's why I chose the greater than symbol. So now let's look at a couple of these problems. Let's definitely do 15. A student is taking a history course in which 5 tests are given. To get a C, he must average at least 70 on the 5 tests. The student got scores of 74, 82, 16, 68 on the first 4 tests. Determine, in terms of an inequality, what scores on the last test will allow him to get at least a C. Recall when you're working with finding an average that you add up the test scores and divide by the number that you have. We know that we have 5 tests, so we have to add all 5 of them up and divide by 5. So I have 74 plus 82 plus 60 plus 68. So there's 4 of the 5. Now remember, they want us to find out what is the last test. So we don't know what that is, so that's going to be my variable. So plus x. So here's my 5 test scores. So I'm going to add those up and I'm going to divide by 5. That's how you find an average. Now we have to be at least 70. At least 70 means I can be greater than or equal to 70. So here's my inequality. Now I can solve. The first thing I definitely want to do is simplify my numerator. So I need to add 74, 82, 60, and 68. When I add all those up, I get 284. So now I really have 284 plus x divided by 5 is greater than or equal to 70. Now, wouldn't it be great if I could get rid of that division of 5? So that's what I'm going to do now. So to do that, I have to multiply by 5 because then my 5's cancel. And what I do to one side, I have to do to the other. So now I have 284 plus x is greater than or equal to 350. Now subtract 284. And that's going to give me x is greater than or equal to 66. So what scores on the last test will allow him to get at least a C? Well, as long as he gets a 66 or higher, he will get a C on or for the final grade.